Hello again, guys. So this is the last topic for chapter 16, which is the separation of ions by fractional precipitation method. Okay. So in reality, if we are extracting mineral ores, okay, in the natural resources, we get mixtures of different compounds. For instance, if we extract barium sulfate from the soil, the barium sulfate can also have impurities such as potassium sulfate. Okay, so this means that if we extract a compound or a solid in a natural resource, okay, so it may have impurities, or that means it is 99 or 90% of what we are extracting. Okay, so how do we separate this? Okay, so take note, we have barium sulfate and potassium sulfate. Okay, so we have the impurities, potassium sulfate. Okay, and we are separating now only the ions, since one has barium, one has potassium. They have both same anion counterpart, which is sulfate ion. Okay, so how can these two ions be separated? Okay, so we will take a look at their KSPs, or the solubility product constant. So the KSPs for the compounds containing barium and potassium, or the KSP of barium sulfate and potassium sulfate, okay, so they will be used in the separation of ions. So for example, so if you take a look at the solubility product constant of barium sulfate and potassium sulfate, the solubility of barium sulfate is decreased that, or is much less than the KSP for potassium sulfate. So since this barium sulfate and potassium sulfate solubility in water is very much so they are wide apart, so we can utilize this KSP values to predict and to determine how much of an added ion is needed to precipitate out one of barium or potassium ions first. So let's have a problem regarding this. Okay. So solid silver nitrate is slowly added to a solution containing chloride ions and bromine or bromide ions to separate these ions, and they are given the concentrations initially of the chloride and bromide ions. What concentration of silver ions is needed to precipitate as much silver bromide as possible without precipitating silver chloride? The KSPs are given for silver bromide and silver chloride. Okay, so let's analyze first the problem. So if we have a beaker, okay, containing these two ions, so we have chloride ions and bromide ions. And then what we need is first to get these ions separately. Okay, so we will use silver nitrate, since silver chloride is insoluble in water, thus it will precipitate out in the solution, as well as silver bromide. It is also insoluble in water, thus it will precipitate out in the solution. So how do we get first the silver chloride or the silver bromide? Okay, and in the question, so it tells that the silver bromide first will precipitate before precipitating the silver chloride. And the question asks for the concentration of silver ions or the concentration of silver nitrate ions that will be added to precipitate this silver bromide, okay, without precipitating the silver chloride. Okay, so how do we solve this problem? So first, we need to get the concentration of silver ions that is needed to precipitate the silver chloride, and then get also the concentration of silver ions that precipitates the bromide ions, and then the range for that. Okay, so that is the concentration needed to precipitate the silver ions or precipitate the silver bromide without precipitating the silver chloride. Okay, so please do the calculations first, and then we'll check if your answer is correct. Okay. So we have two parts for the solution for this problem. So the first one is in silver bromide. So this solution of silver bromide, so it will give you Ag plus and Br minus. The Ksp for this reaction is Ag plus concentration times Br minus concentration. Okay, so getting the concentration of Ag plus, okay, so we'll divide both sides by the concentration of Br minus. So we have Ksp divided by Br minus. So the Ksp of silver bromide is given, as well as the bromide ion concentration, which is 0.020. So dividing this, it will give 3.9 times 10 to the negative 11 molar. So this concentration is required to precipitate the bromide ions as silver bromide. Okay. And then we'll do the same calculation with silver chloride. So this time you will get 8.0 times 10 to the negative 9 molar. So this means that we need this concentration of silver ions to precipitate the chloride ions as silver chloride. Okay, so the question asks for the concentration of silver ions that could precipitate the silver bromide without precipitating the silver chloride. Okay, so the range of the concentration needed to precipitate the silver bromide, so we have the 3.9 times 10 to the negative 11 up to 8.0 times 10 to the negative 9 molar. So this is our final answer. So beyond this, 8.0 times 10 to the negative 9 molar, we will still get silver bromide, but at the same time, there is also silver chloride as precipitates. Okay. So going below this value, 3.9 times 10 to the negative 11 molar, there will be no precipitate at all, since both silver bromide and silver chloride requires these concentrations to precipitate out. Okay. So that was it for chapter 16. I hope that you learned this last chapter for the equilibrium. So in the next chapter, we will proceed with another topic which is still related with equilibrium, but will not use these calculations anymore.